Audio good? Ayan. Hey, good evening, everybody. Thanks for coming to GoManila, our February meetup. So yes, I guess if you were following, we canceled the January for obvious reasons because of the Taal explosion. But we're back, and we have two great speakers with really, really good topics for you today. So I guess to introduce the first speaker, he's a systems engineer at Brankas, actually one of our newer hires, but he's been in the company for, I guess, six.
So yes, I guess if you were following me in January, obviously.
Let's try that again. So please welcome Mr. Carlos Daroya.
Okay, hi everyone. So let's wait for my slides. Okay, cool. So again, hi everyone. Go is a hyped up language, but let's not talk too much about that. Today I'm only here to show you how it looks and feels like to learn Go. And the purpose of this talk is to help you start right by showing my mistakes and ultimately getting you familiar with the language. But most importantly, I just want to share the knowledge that I've accumulated for the past 6 months. And I'll do that by showing a Go curve. A curve I made up, which is called the Go curve. Next slide. So before everything else, a bit of background. I'm a systems developer in Brankas, and we do all our stuff in backend in Go. I have 6 months of experience with Go, and these are the other languages that I've used, the other frameworks that I've touched, and the other tools that I've also used. And yeah, I'm a bit of a programmer myself. Anyway, what does the ideal Go curve look like? Next slide. So it's not actually a curve. It's just a line with a slope of 1. Because ideally, when you put in the amount of time and effort, then you would get the proportional amount of learning, right? No, it doesn't always happen like that. Next slide. As you can see, this is my Go curve. As you can see, life is not always a straight line. And so, first, I learned the syntax exponentially in an exponential rate because I was cramming. And then I encountered a lot of critical points after that because, of course, learning the syntax would have its side effects. So there are a lot of learnings and unlearnings in between. But afterwards, when you get to learn the essential, then you achieve a point of harmony where, again, the line becomes constant with a slope of 1. But yeah, that's a wish, but I hope I'm already in that phase. But to avoid this, start with the most fundamental of them all, which is the syntax. Next slide again. So we'll just dash right through this because I'm pretty sure you guys are all experienced programmers anyway. So, okay, next slide. So this is how you do Hello World in Go. First, you import the FMT package, and then you access the method called println using the dot operator. So fmt.println and then some string. That's how you do Hello World in Go. Simple, right? You've already learned 90% of the language. Just kidding. Next. This is how you declare variables in Go. There are 2 ways to declare it, statically or dynamically. This is how you declare statically. You explicitly code the type. So int, boolean, string, float, and then you assign some value to it. So yeah, that's how you declare variables statically. And then the other example is, next slide. This is how you declare it dynamically. You use the colon equals operator, which is this. And then you don't have to define explicitly say the type anymore. You just input the value, and then it would infer the type from that. And then a bonus, this is how you define arrays in Go. So int array, string array, and then this is a map. It's basically the dictionary in Python. And this is an example of a map that takes in an integer and then returns a string. Okay, next. This is how you write. It's the C style, Java style, so I'm pretty sure you're all familiar with this already. And next slide. This is how you do an enhanced for loop. Basically, you use the range keyword, and in this example, you loop through the strings array, the animals array, and then you just print everything. Okay. Next, declaring functions. This is how you declare functions. You use the keyword func, and then followed by the name of the function. Next slide. So this is an example of an add function. You take in two variables, x and y, and then you add them. And then you have a return type of int. Okay, next. Next. So that's pretty much it for the syntax. There are only 25 keywords in Go, so you can probably already infer what the meanings of the other words are. And yeah, since there are only 25 keywords in Go, it's pretty easy to learn. But be careful. Next slide. Because since it's easy, you might already have a lot of assumptions right now on how to program in Go. But it can get really visually complicated. So an example of a complicated code is, next slide. Next slide. So here, this is an example of closures. But basically, it looks weird. But basically, you're just defining a function called closure. So this is the function name, and then you have a return type of of a function, another function. So Go has that capability of having a return type of a function. And then here, we're just defining a function as a variable. So this inner func is actually an anonymous function that was defined in line. So yeah, more on this later, but remember to just be careful. As long as you know the fundamentals of the syntax, then you're good. Next slide. So now we're done with the syntax. Let's move on to the concepts. Now, so I've shown you the critical points phase, right, where there are lots of ups and downs. So this is where I encountered most of them. Next slide. And in particular, there are three important topics we should cover: structs, implicit interfaces, and closures. So let's start with structs. So there are no classes in Go. So there is that misconception that since there are no classes, you can't do OOP. But the thing is, we have structs. We have powerful structs in Go. If you're not familiar, structs are concrete blueprints of objects. And it's very similar to classes. But the thing with the structs in Go, you can attach methods to it. So, yeah. So OOP is doable in Go. To actually understand this, I prepared an example. So next slide. Okay, let's go through this one by one. So we are defining a struct called dog here, and then we are attaching a method called noise. So you can access this noise method using the dot operator, something like this. So first you instantiate the object, so something like this, and then you access the method called noise like this. So as you can see, yeah, you can pretty much do OOP and go. Next slide. Next are implicit interfaces. So interfaces were kind of tricky for me because I didn't fully understand interfaces at first. But they are non-concrete blueprints. So unlike structs, which has field, in interfaces you only have functions. So in Go, interfaces are implicit. So it automatically detects if an interface is being followed. So unlike Java, well, I'm only familiar with Java, which has the implements keyword. In Go, it just automatically detects if some object X follows an interface Y. And if you're not familiar with the purpose of interfaces, just relate it to polymorphism, and we'll see that in an example. Next slide. So, okay, we'll do polymorphism with the dog and the cat struct, since they're very similar. So, okay, we define two structs, a dog and then a cat, and then we define a method for both of them called noise. So this one is attached to the dog struct, and this one is attached to the cat struct. And then finally, we define an interface called animal, which just says that, okay, if an object has a noise function, then it must be an animal. So now to the now for the polymorphism part. So the other side of the slide, we define a function called makeNoise, which takes in the interface animal, right? And for the fun part, so we use the makeNoise function here. And as you can see, we can input either a dog or a cat inside that function. And it won't matter because, and it would run successfully because Go can detect that it follows the animal interface. Yeah, I hope you got that. So interfaces are pretty useful for consolidating your code, and for if you have very similar structs that have very similar functions, then you can just consolidate them into one interface, and then you're able to reuse your code. Next slide. When you're starting to learn Go, you will be encountering these codes a lot in some blogs or whatever. So first it says that accept interface and return structs. So we already did this in our example. Can you go back a slide? So in our example, we are accepting interfaces in our makeNoise function. And we do that because it's more flexible. Imagine if we are actually accepting the dog struct. Then we can't input the cat struct in there, right? So we accept interfaces because it makes it more flexible. Okay. Next. And then for the define interfaces at the point of use, you'll also be encountering this a lot. So, can you back slide. So there's one wrong thing about this example, and that is we are defining the interface here. We should be defining it on the other side, which is the point of use. So that's what it means to define interfaces at the point of use. Okay, 2 slides next. So now, closures. Closures are a tricky concept to learn. It was very hard for me, but it's very similar to decorators in Python, if you're familiar with that. But honestly, the syntax is quite new. Was new to me, I mean. So in order to learn closures, you have to learn 3 concepts in particular. So we'll go through them one by one. So first is first class function, which only means that you can define functions as variables. So similar to how you can define booleans, ints, and whatever stuff, you can also define functions as variables. You already saw that earlier. Next is higher order functions. So we can also define functions, we can also input functions as parameters to other functions. Okay, and next are closures. Okay, I won't even bother. Let's just see the example. Sorry. So this is the first class function, defining functions as first class citizen. So yeah, this is a variable local add, and then you instantiate a function here. And this is local subtract. The same thing happens, but it's for subtract. And this is how you use it. So local add, then execute the function, local subtract, then execute the function. Okay, next slide. Sure. So, next. Next. And okay. So next is higher order function. It only states that you can define functions as parameters to other functions. So here we are defining a function called executor, which takes in a function of type this. So a function that takes in 2 integers and then returns an int. So we can use this function like this. So executor, and then you have a parameter of a function. And then it would output 30 since we are adding 30 inside the function. We are using the add function inside the executor function. So now that you've learned those two, you are ready to learn closures. Next slide. So we already saw this example earlier. We define a function called closure that has a return type of a function. And then we are defining the function that we want to return here. So the variable inner func is a function, and then we return that. So what happens in this example is we return this function inside, and then we use it on the outside scope. So when we execute this function out inner func, then we are actually incrementing the values from the counter variable inside the closure function. So this was a very tricky concept for me to learn because I thought at one point that functions are temporary. So whenever the function is done executing, then it would throw away everything, right? It would throw away all the variables inside the function, the context of that function. But with closures, you are actually returning. You can actually modify the counter variable from the outside scope because you are returning the function that modifies it. So as long as you understand that functions are not temporary and it can be modified from an outside scope, then that is basically the essence of closures. Next. So the most important use case of a closure is for middlewares. So here is an example of a middleware where, remember this add function that we defined earlier. So it takes in 2 integers, right? So we wrap it inside a timer function, which just, honestly, it's a makeshift timer function which just prints start and end and does not actually time. But, okay, so this is the add function, and then we input the add function into this parameter, into the first parameter, and then we execute that f variable here. So, yeah, and then you use it in the main function like that. So we just put the add inside as a parameter for the timer closure. And with that, the output would be start, 30, and end. Because as you can see here, we are wrapping the execution of the add function inside some other functionality, which are just prints. And closures are very important because one example of a real-life application of closures is through input validation. Let's say you have an endpoint that you want to have some validation of its inputs on. So you just define a function called input validation, and then you do whatever validation you do, and then you wrap your endpoint inside that closure or decorator. And yeah, next slide. So those are the three important concepts. So structs, implicit interfaces, and closures. And now to the final chunk, practicalities. So I actually wanted to demo some code here, but I got too lazy. So let's move on. Next. So the first step to the first practicality that you should learn when starting Go is how to organize your files. So you can't just put everything in the main function, right? Because only mad lads do that. Instead, you can separate the functionalities into separate packages. So here, example, package main or package dog. Yeah, you can separate your files into packages. And the important concept that you should learn is knowing that when you define a capitalized variable or a function, then it means that it's exportable. And if it's uncapitalized, then it's not exportable. So it's similar to public or private modifiers. So as an example, next slide. So here we are just defining two packages, so a package dog and a package main. Inside the package dog, we are defining a non-exportable function called noise and an exportable counterpart that is also called noise, but it has a capital letter. So we can use this exportable function like that, since it has a capital, it starts with a capital letter. But if you try doing dog that small letter noise, it won't work because it's not exportable. And this is how you import the package, actually. So you just import the dog package. So next slide. Next step to organizing code is using GoMod. So, wait lang. I think, can you back? Okay, GoMod. So GoMod is Go modules for short. And it's a dependency management tool in Go, and similar to NPM, Maven, and pip. And the thing with Go is there are no relative or absolute imports. There are just module imports. So you can't do something like ... / and then followed by the file name. You can't do that. Only module imports. So it would look something like this: import, module name, and then the package name. Next slide. So, okay. So here, so the reason why the import looks like this is because I defined a module, I initialized a module called Brankas, brank.as./x. So that's the command that I use, GoMod init. And then, yeah. So basically, this is an example of a module import. And then GoMod automatically finds these for you. Next slide. You can also do import local and remote packages. So as you can see, we are already importing a local package called dog. But we can also import third-party packages, something like this. So in this case, we are getting the logros package from the repository in GitHub. So, and then this is how you access a method in the logros package. So logros.fatal, whatever. So honestly, GoMod is a pretty big topic and it deserves a talk of its own, but that's for next time. Next slide. So now we're done with the organization of code. Now to just familiarize you with some of the important libraries. So we already know FMT. We used that to print the hello world earlier. And then strings, math, bytes, and errors. These are just analogs to the same packages in other languages. Self-explanatory. Then next is net HTTP, context, and database SQL. Uh, if you are planning on coding, on doing some web development, then that would be pretty important to start your server and then to execute calls to the backend, to your SQL backend. You should just note on those libraries. Next slide. And next slide. So other specific and useful libraries. So testing, obviously it's used for testing. First things first, every package in this list actually also deserves a talk of their own. But so an example of a use case. So let's try crypto. Crypto is a package that would help you encode or secure your endpoints through cryptographic means. So for example, you want to hash your password so that it won't appear as a plain text in your database. You can use the crypto library. Next slide. So next practicality that we have to learn are the resources. So this was one of the main setbacks that I had when learning Go, because I always relied on Stack Overflow, because every question that I was actually asking was already answered in Stack Overflow. But since Go is young, it doesn't work that way. So here we should identify some alternatives, and these are some of the alternatives. So first is scaling through GitHub issues. So yeah, scaling through GitHub issues. And then next is joining the Gophers on Slack channel and actually communicating with other programmers that know their shit. And then reading through the source code, or reading through the source code of Go. And the thing with the source code of Go, it has comments that are comprehensible by humans, so it is doable. Next is Go documentation. Go documentation. Just search for it. And Go blog. So Go blog is very important because it would give you some important opinions, actually, of what are the right practices, the best practices, and what are the common and uncommon. So the Go blog is written by the actual Go team, so it is one of the most reliable sources. And then, Stack Overflow again, because it would help you sometimes. Sometimes the questions have already been asked. So if you're lucky. Next. So other resources that I've used. So the Go programming language book. And then Medium and GitHub, there are some blogs and articles that are very useful. Tutorial Edge. If you're not a reader, if you just want to watch some tutorials on your free time, then you can visit their channel or their website. Then these people, I'm not sure if this is a person, but these people are one of the easiest to understand their blogs are the easiest to understand. So, yeah. Next slide. Now that I think we're done, so congrats, we're done with the talk. So there are 3 key takeaways for this talk. First, learn the syntax because that's the most fundamental of them all. And if you start wrong and you have wrong assumptions, then it would be messy uh, in the middle. Next is concepts. So just remember that structs are a rough equivalent to classes, so you can do OOP. Interfaces are used for polymorphism, and in Go it's used implicitly. Closures are like decorate, the syntax is different. Next, practicalities. Learn the standard library organizer code. I forgot to put it here. No need for frameworks, and know the proper resources. So, yeah, next slide again. So I hope with this talk that if ever you plan on taking this route, don't. I hope that with this talk, your graph would look more smooth and more easy, and something like this. I hope this talk helped you. So next slide. Thank you for listening. Yeah, hope you learned something from this talk.
If you guys have questions for Carlos, we can pass the mic around. Does anyone have questions they want to ask about the talk or Go in general? Yes? No?
Thank you for not asking questions.
Miggy has a question. No? No, it's...
Possibly any questions
yeah,
you might
if you have... Okay, here.
Okay, good evening. So this is the first time I've heard about Go language. So may I know or may we know what have you done about, or what have you done? Any project about?
So I don't have any particular pet project of my own, but and so fun fact, this is my first job out of college, and this is the first time that I've actually used Go. But in Brankas, what we do with Go is we use it in our backend. So from executing your SQL queries and stuff like that, and then our infrastructure is also our infra is also mainly written in Go. So you can also do, I'm not sure what that's called, but so scripting. So you can do scripting with Go. But yeah, I'm a backend developer, so I mainly use it for making features and then making features and then yeah, that's basically it. I won't expound any further. Thank you for the question.
All right. Anyone else have a question? Yeah.
How does Go compare to the other languages that you've used?
I think so. I'm trying not to be biased here, but for me, Go was quite tedious to learn compared to Python, since there are because of the static typing, basically. But once you get used to it, then you are able to actually appreciate the beauty of static typing and how it makes your coding more consistent. It makes your coding more consistent. And another quality of life experience with Go is your code compiles very fast, and it compiles in binary. So you don't have to wait 10 minutes to push to staging or production. It's very fast and yes, easy to learn.
Any other questions?
So is this, your application, is it deployed on your own servers, or are you guys on the cloud? Or
Right now, we are using GCP for that's where our code is deployed. But we are planning on migrating to our own on-premise servers.
So for right now, you guys are or cloud computing.
Sorry.
So GCP, right? So is it App Engine that you guys? So in GCP, there's 3 different ways that you can run your own code. So it's either, but that's okay. Okay.
Oh,
So you guys are running it.
yeah. So I kind of don't know the answer to that question.
Yeah. I think the next speaker can answer that.
Yeah. Maybe ask our CTO or on the next talk.
I have a question for you. Did you actively, so when you joined Brankas, were you actively looking for a Go, were you actively looking to develop in Go, or did you just like, I guess, quote unquote, fell in love with it on the job?
I wasn't actually looking for a Go job, but I was actually looking for a blockchain related job. So that's the funny thing. Brankas doesn't do anything blockchain related. But when I first, but that's the thing. When I learned about Brankas, I learned about Go, and then I understood the hype. And I was thankful that my first job would be something that.
Anyone else? Okay. Thanks, Carlos.
Okay. Thank you, everyone.
All right. Yeah. So it would be awkward if I was sort of like to pitch you guys what Brankas is. So because I'm also kind of hosting GoManila. So in order for me to kind of like transition out of that awkwardness, I'd like to introduce you to my fellow product manager, Luis, who will be introducing Brankas to you guys.
Yeah, hi everyone. Yeah, I'm Luis. I'm a product manager at Brankas. It's like we're a financial technology firm. We deal primarily with enabling open banking APIs. It's like, so that's both, enabling this kind of like open banking API infrastructure for banks, while also at the same time creating this sort of platform for financial services APIs that aggregates financial service APIs for third-party developers, other aspiring fintechs to kind of integrate to and gain access to these, to all of these banks. Yeah, and it's like we're the sponsors of GoManila, so we build everything on Go. A couple of other technologies, but everything primarily backend is built on Go. And we're constantly hiring. It's like we're constantly hiring. We're always on the lookout for new talent. So it's like if you guys are kind of interested in learning more about what we do and maybe potentially exploring possibilities with us, it's it's like we're always hiring. It's like we're looking for more backend developers. It's like front end devs. For our front end stack, we're primarily just HTML and Vue.js primarily. And also always looking for product people. It's like whether you're more on like the product marketing side, the UI UX side, or like straight up product management, we're always looking for hungry aspiring and talented people to join our ranks and to kind of help us build out the open banking API infrastructure of Southeast Asia. So yeah, we're present in how many countries are we at right now? 5 different countries in Southeast Asia. And yeah, it's like Philippines is actually one of the larger regions where we have a larger office, a lot more team members are located here in the Philippines. But yeah, we have a presence in Indonesia, which is also fairly large. We're up in Thailand, Vietnam as well. We also have a presence in Singapore. So yeah, if you guys are interested, or anyone who might be interested, if they enjoy Go and financial technology, if they enjoy building APIs, it's like, please, it's like send them our way. We're always looking for talent. Okay.
So the Brankas people are going to be around while we do our, refreshments later. You can ask them. We can give you our cards, or you can visit our website, brank.as, and you can go to the /careers, or the careers page, and you should be able to. Hello. You should be able to see what's available for you guys. And also, so I'd like to point out we're also a remote first company. So basically, most of our engineers, product managers, and a lot of our staff work remotely. So if you're into that kind of thing, please check us out. Anyway, so for our next speaker, he is our chief CTO of Brankas. Oh, hey, Ken. There you go. Yeah, he's actually sort of like a veteran in the regional tech industry. He's been here a while. He's a former, I think he was former CTO also of Multiply when they were still here. Yeah, and so to give you a really interesting talk about building a search engine for fun and profit, aimed at basically showing you guys what's possible with Go as a language. Here is Ken Shaw.
Hey, can you guys hear me? Oh, awesome. Is there an echo? No, okay, cool. All right, let me, can you guys see my camera or not? Oh, you can, okay. Because I'm watching the YouTube stream, but it's like 2 or 3 minutes behind, so like I don't really know what's seeing, but going on. Here, so this is the real brains behind the operation here. This is my little son. He wanted to sit here with me, but he's gonna go downstairs. Hey, you go. Yeah. Okay. Thank you. Okay, so as they said, I'm Ken Shaw. I am the CTO of Brankas, and I have been coding Go for a very long time, like not quite 10 years, but I don't know, something like 8 years. I don't know. It's been a while. So tonight's presentation is basically going to be on building a search engine for fun and profit. I don't have a lot of time to present this, but I wrote something like 2,000 lines of code for this presentation tonight. So, hey, can you guys still hear me? Okay, great. I'm just gonna really reduce this because maybe you guys don't have an echo, but I have an echo. So anyways, apologize for the presentation, but I'm doing this tomorrow night as well for a different meetup group here in Indonesia. But as Luis and Marco and Carlos mentioned, I'm the CTO of Brankas. Brankas is a interesting company. If you guys are interested in a position, please email us careers@brank.as. We're looking for kind of all positions and hiring for all positions at the moment, especially engineering or things that you might be of interest to you. So everything I'm going to demonstrate here tonight is already online. So if you want to follow along at home, feel free to do go-get-u or just do git clone and be able to check it out in your local repository. So this presentation is a little different than I would do because what I normally would do is I would, basically show the code and sorry, no, let me rephrase. Actually, I wouldn't really just show code. What I would do is I would actually do explanations in depth. What I want to do here tonight, and what I kind of want to accomplish, is I just want to kind of showcase what is accomplishable with a very, very, small amount of code, at least compared to other programming languages that you can get done with Go. And what I want to do with that is basically show you how I build and structure apps personally. There's no real quote-unquote right or wrong way to build applications, but I have something like almost 8 Go code almost exclusively. So I'd like to think that I have at least some amount of informed knowledge. I have multiple packages in Go that are, have more than 5,000 stars on GitHub. If that's popularity contest. That metric mean to you. But anyways, what I'm going to show you here tonight is how I would build a very, very, very simple search engine. And what we're going to do is implement this quote using microservices. They're not really true microservices in the sense that they talk to each other and whatever. But I'm just going to show you kind of how I would set it up. It's going to be basically a 12-factor app principles, and you're going to be able to deploy this locally and remotely using the same configuration. And you're going to be able to run this basically at Google scale. Originally, this presentation, before I realized I just didn't have enough time to demonstrate. Sorry, what was it, Marco? Marco, are you talking? Okay, so is that okay now? Okay, what was the issue? Okay. So originally I was going to show how I would actually deploy this in production using, basically compare how I do development locally versus doing development, quote unquote, on the cloud using Kubernetes, but basically using the exact same code base and the exact same configuration. Well, as much of a configuration between the two as you can share. Of obviously using Docker, using Docker Compose, and Kubernetes for deployment, but I really am not going to have time for that. So let me. So this is going to be a little complicated because I have to use two computers because of the I don't know whatever it is. Chrome will not pick up my terminal on Linux now, whatever. So can you, Marco, can you click over to the to my terminal? I'm going to start showing and discussing what's going on here. So as I mentioned, this is so one of the other things that I'm doing differently with this that I don't really typically do is that I'm using a lot of my own packages in this implementation, and I'm making a extremely complicated application. But I am not exaggerating here when I say this is ridiculously overly complicated, more than it needs to be. But I've done it in a very efficient manner, in kind of the same kind of way that a company like Google might do or Facebook might do, just to kind of showcase how quick you can actually do this. But basically what I'm going to talk about is that the actual application, all it is a simple web front end. It pulls data from a database, formats it, deploys it as HTML, and I'm going to basically start off with the SQL schema. Right here, this is the actual Postgres schema that's being used. All that's going to work is is it better with colors or not? I don't know. Okay. Well, you had mentioned you can see the red or whatever, but it's not really that big of a deal. There's not a lot of red on this screen. So all I'm going to do is create a very simple schema. All it is I'm just going to track web pages. So what I built here tonight, what I'm going to show you is I actually have a full working web crawler implementation that will crawl a website. They will basically get all of the links that are on a web page, queue them up for retrieval, and and write them to a database. And this is just the simple database for now. Obviously, if you were writing something like a real Google, system like Google, you wouldn't use a relational database, but this was just quick and expedient. And what it also does is it kind of showcases you. It also does is what it showcases for you is how you can kind of layer very simple technologies to get something much more complicated and advanced. And to just kind of give you an overview of what this schema does, all I have is just a pages table, i.e., various URLs that have been visited by the crawler. We're letting the database handle most of the logic, and I'll go a little bit more into detail on that because I'm doing a lot of it in the actual Go code. But we've got the page ID, the location, i.e. the URL, a header from the original request, the body, the title, the words, and then this is kind of the fancy thing that enables the full text search. And then I've just got some timestamps here to kind of mark how things have been pulled in the database. So just to show you what's going on, what I have on the actual package, on the actual build is that everything is self-contained in 2 files. I've got the crawler and the search engine. And what I'm going to do here is I'm going to go here so I'm going to schema, and then I'm going to edit the command, and then the 2 commands. Okay, so again, this is the same schema, very, very simple. This is the crawler, and so I'm going to go give you a quick overview of how the crawler works. I am actually the author of Chrome DP. Instead of using Chrome DP, though, I just decided to use GoQuery just because I wasn't really trying to do a full, Chrome-based crawling experience. But I'm just going to take you quickly through how I've written this application. So you have your main entry point. So everything is self-contained within this file. It's 367 lines of code, and what I've written in this 367 lines of code, this thing will, if you let it go unchecked, will literally crawl the entire internet. I am not exaggerating that it has the capability of doing that. I really had this crawling IMDb, and I was going to showcase how to, basically do a quick search on IMDb. But IMDb banned me earlier today. I guess I was hitting their website a little too much. But anyways, all I have is in this app, I have 2 flags, command line flags that are being passed, and then I'm parsing it. And this is in the main func. Before then, I immediately switch control to the run. This is kind of really how I structure all of my command line applications these days, is I have a single run entry point, more just because it simplifies error propagation. And what's different about this crawler is that this crawler is a multi-worker queue-based crawler. And I'm using this hierarchical queue package. You can see here on the dependencies, it's this BG Adrian data structures priority queue or whatever it is. I have it linked in twice. Oops. That means there's someplace I'm not using the package alias, but not a big deal. Anyways, all I do is I'm using that priority queue to just basically prioritize crawling tasks over tasks that write to the database. And what the crawler does is that it basically sets up 3 streams of work, and it has a number of workers that work through that priority queue in order to get that done. But kind of the way that this works is I just open up a database connection. I store it in my state, and then basically I create a new hierarchical queue. That's what this is here. And then I build an actual caching HTTP client that uses one of my own packages, Disk Cache, which is relatively new, but it's just kind of a culmination of a number of years of. If you want to see the implementation, this is what it does. But basically, what I'm doing is I'm just creating a new HTTP transport. And what this does is I'm actually using my local cookies from Chrome using a third-party package called Cookie, K-O-O, like Cookie, like K-O-O-K-Y, to basically load Chrome, to load cookies from Chrome so that I don't get banned. Anyways, that all this does is it creates an HTTP client, which is then essentially used for the actual data retrieval later, which I will get into shortly. Let me go back kind of to the original flow. Marco, by the way, if there's questions or anything, since I can't see the audience, please let me know, because I can't hear you guys either now. By the way. Okay. All right. So I'm using. So what I've done is I've designed this this task worker to basically monitor the number of errors that are tracked, and that's part of this state here, which is the error count and the total error count, which is basically over a number of ticks. In the Go standard library, it really makes these kind of asynchronous, operations very easy to basically handle. And then I just kind of basically do some program cleanup. There's the build client func again. But here's the actual worker logic, and I want to show you that it can actually fit on a single screen. It is a total of, I guess, 28 lines of code, but this is what the actual worker does. So all the worker does is it checks the context. If the context has been finished, if it does, it exits. Otherwise, it takes a task off of the priority queue. It checks to make sure that the priority is not worked, and then it basically executes that task. And what I want to say in terms of like why it is a task, what I'm doing here is I'm casting. This priority queue is like a general data structure, so you can use it. It takes basically the empty interface as its storage type. But what task is here is that it just basically allows me to define multiple quote unquote work tasks that can be executed in the same way. And I've defined task here as just having a simple exec function, which again takes a context. I'm very much now into these days about writing everything using context these days. It just kind of makes the most sense. But going back to workers, but this is basically what this does is then it then executes that work task. If there was an error, it records it on using the atomic functionality. And then here basically we get into what the actual different types of work are. And this kind of, I know that a lot of you might be fairly new to Go, and so this might be quite difficult for you to understand. But what we have here is basically a scrape work task, which just basically wraps a URL string and the current state. And what it does is it then just retrieves it. It uses the Go standard library for HTTP requests. It forges the user agent on the header, and then basically uses my caching disk client or disk transport, I should say, to just basically make sure that we're saving that data. And then it does some basic post-processing of basically splitting out the response header from the response body. and then it's queuing up a new task to process that data, which is here. Now, processing a scraped page, basically just encompasses the URL string, the header, and the body. And all the new process thing does is it just basically creates a new process using the and process thing. This isn't strictly necessary to do it this way. I just kind of prefer the functional semantics because it makes it slightly easier in the future to change the API when and if you need to do it. But again, this process work task, what this really does is it processes the retrieved data and then essentially then adds a third work task of storing it to the database. But what I'm using here is the Go query package to basically load that HTML content. I'm using the API to basically find the title and the body. What I'm doing is I'm actually doing the text, because what I'm using the text for is I'm going to inject that into the database for basically using the full text search. I'm going to get into that. We don't really need to go into what all of this does, but just understand all of this does is it processes at a very high level the actual HTML data, strips out the information, and then basically grabs all of the A tags. That's what this bit does, and then queues up new work for all of the scraped href, the A tags with hrefs. That's what basically here is doing. It's looping through the hrefs and then adding a new scrape task, which we saw above, and thus kind of creating a closed loop on the entire system. What this one here is creating is the new database insert. So this is the separate database actual inserter. And what it does is it does a simple database insert using the SQL database and the Postgres driver to do that. And I want to show you how I structure my actual inserts into a database. I want to emphasize here, I don't use ORMs or anything like that. Instead, I'm just using raw SQL, and I'm taking advantage of the features in Postgres. So what I'm doing here is, I know this might be quite complicated from an insert semantics, but this is actually a quote-unquote upsert statement in Postgres. What it's doing is that it's doing an insert. Let me put the two schemas next to each other so you can kind of understand that on what the insert is doing. If you see here, I have this as a primary key on page ID, but I also have a unique index on location, meaning that there can ever only be one entry in my database for a specific URL, and that is the canonical URL that is generated by the request, essentially. And what you see here is, what happens when there is actually a conflict in the database on that location. What I'm doing is I'm essentially doing an update statement instead. And what's really nice about this is that this is the entire database logic. There is no other database logic other than a retrieval statement that I'll go over later. But I just want to kind of point out, there is extremely high-level functionality in things like Postgres and other things, and I'll demonstrate now what this crawler actually does. So just to demonstrate that I'm not lying here, that it actually works. So build command search, oops, crawl, oops. Go off. Okay, sorry. So the reason that's off is because I haven't updated the dependencies on the Go module and Go sum files, but I had added an additional option to, because I had found a problem with my disk cache mechanism, but whatever. Okay, but notice the Go build actually worked. I'm not lying. So let me demonstrate to you what it does. And the screen is going to go by extremely fast right now. I clocked this at doing a little over 1,500 pages per second. I don't know if it's going to get that speed now, but let's see. Oops. Oh, I am not running my. Oh, that's right, because I see USQL contrib docker run. So I gotta recreate a database real fast. Sorry. Okay. Cat schema. Shit. Hey, give me 1 second. I forgot that I killed the Docker image when I restarted my computer to try to fix this. I don't use persistent images. So I need to recreate the schema real fast. Okay, so all I'm going to do is I'm going to just copy and paste this manually. I wouldn't usually do whatever. All right, so the schema is real. It worked. I already created it. So what I need to do now is I just got to set up some environment variables just because it makes it easier. Sorry, I had rebooted my system. I had all this set up. Okay. All right. So what we're going to do now is we're going to just run the crawler, and it's going to go fast. And see, already it's getting a bunch of errors. The reason for that is my U limit is too low, 677. I'll set that again. There you go. That's literally a bunch of pages that are being downloaded and retrieved and set to the database. Okay. So I'm not lying. It's working. It's crawling. Again, I just hit Control C to kill it. As you can see from pages. All right. So I literally captured 3,702 pages in however many 10 seconds, 20 seconds, 30 seconds I ran that. So it's great. Select location from pages, limit 15. All right. As you can see, I captured a bunch of crap that is not really relevant. I really wanted to showcase kind of, the search engine aspects. So what I'm going to do is I'm going to maybe let this run, crawl, dev null. I'm just going to let that run in the background until it either craps out or whatever while I'm doing other stuff. Crawl. All right, it's still running. So let's see how many pages there are. So PSQL cache DB -c select count location from pages. All right, still at 3757, huh? Index out of range, 4096, huh? Okay. I don't know. Let's, obviously my code is not perfect, but I think that this is in I think it's in this priority queue implementation, which I did not write, but that's okay. It should have enough information that it's not a big deal. And what I'm going to do is I'm going to run the search engine and basically demonstrate what the search engine actually looks like. So Marco, if you switch it back to my other system or my other shared screen, you have this search IMDb thing. So let's search for something like cool. And I'll show you basically here. So here's the actual UUIDs from the system. Here are the actual. Okay. So we have all of this stuff. So this search engine is actually returning for the poor formatting. But I'm going to take you through the actual search page implementation on how I actually accomplish this. I can search for WWE, I guess, WWE, and show you exactly how that's going on and how I accomplish that. So I'm going back to the console now, Marco. So you can see what is there and what the UI looks like. Now let me show you how I implemented that. Command search. Again, everything is self-contained in one file. The HTML templates and other things are not, but it's only 150 lines of code in the actual web page implementation. Again, exact same kind of setup. I just have a couple of environment variables that I, runtime flags. I'm just setting that up, immediately switching over to my run implementation. And then I'm doing some other setup stuff that I always do in applications, which is I'm setting up my asset function using my asset package that I personally wrote for myself that literally no one else on the face of the planet uses. But that's okay. So again, doing the same things, I'm opening a database, but additionally to that, I'm then listening on a TCP IP socket on port 3000. And then I am running a server. I'm using my Sentinel package to run this server. And then basically I am starting an HTTP server on that listener and using a new server. And the server implementation here is this. Now I'm taking advantage of Go's type polymorphism, kind of the way that this is kind of the way how you achieve, type composition. I don't want to say object composition or object-oriented programming. It's not object-oriented programming. This is type-oriented programming or type composition in Go. So I'm using this Goji Mux. I'm not the original author of Goji, but I did rewrite it to fix their problems because I did like their API, but the guy who wrote it absolutely refused to include my implementation. But my pull request. So I just ignored him and fixed it myself. So anyways, what Goji is a very high level router for or HTTP muxer, but it does basically path routing, so it allows you to very quickly and easily write some semantics on doing that. And it plugs in and works with my assets package and my generated assets, and I'll get a little into that about how that is. But basically, all I have is just these two web pages. I have the index page with these two HTTP handlers, and then I have the find page that is responsible for returning the find results that you just saw on the web page. The index page is very simple. All it does is it just displays the actual template for the web page, and then find is a little more complicated. It does a search using the past query parameter. And then if there's an error, it just writes a simple 501 error or internal server error to the screen. And then otherwise, it just outputs the actual find page template using the results that are generated via this marvelous search call, or this marvelous func here. So similar to my other SQL query that was actually updating the database on the crawler, this here does not use an ORM. I just am using a raw select statement, but I'm using Postgres's full text search, and that kind of plugs in. Oops, let me open that again as well as schema, split. Let me just show you. So all I have here is I have this TS vector. That's a text search vector in Postgres. And here's the accompanying select statement. So all I'm retrieving is the page ID, the location, the title, the headline, and then using QQ here. QQ is the query. That's aliased here in the query as on the from. I'm using the special web search to TS query that allows you to do some special operators such as not operators and stuff like that. And then basically just executing that in Go and then returning the data. Note that I'm using all of the context-based database queries. I'm not using the plain original ones. That's very helpful because it allows it to propagate context. When you're doing some when you're doing something significantly more complicated than this, that starts to matter. But the way I load results is the same way I've always have done it. I just do the standard rows over next, checking for an error. If there's not an error, then basically scanning the results into a result object, and I've defined the result object inside the templates package. Maybe you might typically do this inside a models package or something. It doesn't really matter. I just did it in the results more purpose, and that's it. That is the entire application. It's 150 lines, and all of that marvelous, wonderful logic that you saw on your screen is completely contained inside this single file. Now, I am using my assets package or my asset generator, asset gen. It's a little complicated, but without getting into it about why this is awesome and great, is that it really basically creates, it's kind of essentially the equivalent of Webpack, but for Go. But I have no intention of supporting it, so don't use it. Anyways, I just want to show you how I lay out my templates. This is my HTML template. This is my find page template. As you can see, it's actually just basically Go code. What my asset generator does is it just basically does a simple Go loop over the results and then displays the results. That's it. That's literally the entire logic. Anyways, that's kind of it. I'm happy to answer questions about how I build Go applications or about how I structure things. I realize that was a lot of content, but it's already fairly.
Can you hear us?
Ken, can you hear us?
Hey Marco, are you there?
Can you hear us?
Okay.
Ken, can you hear us?
I don't know what's going on.
Oh, God.
Can you hear us?
My mic is on too, and she can't hear me. Ken?
I can.
That's.
Sorry, that's wrong. Yeah, my thing is open.
I'll just read. I'll do it.
Go ahead.
Ken, how about now?
Hi.
Better?
I can see you and hear you.
Oh, okay, cool. All right. Awesome. All right. Have you guys any questions for Ken? Anything?
Hi, Ken. How are you?
Yes.
I'm just curious. I noticed that you seem to have not used the Go routines or channels for your search engine. Is there a particular reason why you didn't go for that approach?
I heard about 30% of that question. Sorry, it's not your fault.
Yeah.
Sorry about that.
I can.
Hi.
Yeah.
So the
Hi.
question is, why you didn't use the Go routines for your search crawler?
I
Is there
did.
a particular reason why you didn't go for that option?
So uh, yeah, I I understand that. So there are Go routines everywhere. So it's just you don't realize that they're there. So let, let me. So what I use is I use a high level sync package called Error Group, which allows the different. Okay, so command. Are you talking about in the crawler? So here I'm using Error Group. So Error Group is our Go routines basically, but what they are is they're synchronized Go routines. What's nice about Error Group is that they allow you to propagate a context, i.e., with context statement. And as you can see here, I am using Go routines, for example, right here, that I'm waiting for that error group to complete, as well as in some other locations. But the primary loop here, this monitoring system, so inside this run loop, it doesn't need a Go routine because what it's doing is it is monitoring the number of errors, and then it's killing the context when the number of errors exceeds the acceptable thresholds. Okay, that's what this entire block of code does. That's what this entire block of code does. That's why you have these cancel statements. I'm canceling the context and then forcing the workers to terminate. The reason I do that is that I allow workers to gracefully terminate instead of just dying on the vine. The utility for that is I can show you why that's useful. Let me, so Z29, oops. Sorry, I have it on a remote system. Okay, so why that's useful, so I'm just deleting the cache that I had generated before, and then I'm just running the crawler. Oops, export db equals Postgres, Postgres. Localhost. Okay, so as you can see, these crawlers are going. If I hit Control, notice that the in-flight work didn't die. It only died after I hit that, and then they all got context canceled as the error, as opposed to it being like terminating it in the middle of a disk write or something like that. So meaning that when I retrieve a file from the remote site, it then finishes retrieving it, finishes writing it to disk before it then checks and terminates on its own. That's the utility of like a context, because when you close a context, you don't necessarily expect all of your workers to terminate. You're giving them a bit of time to terminate, if that makes sense. And if they don't terminate, then you can do some other things like manually kill them if they don't terminate, or if they don't end in a safe amount of time. But if you propagate your context properly all the way down into your API calls, then they will immediately stop whenever they can, if that makes sense. Yeah. Okay.
Any other questions from the audience? Yeah, come in. Sorry, you'll need to come near because we haven't figured out how to pipe the audio to Ken.
Hi.
Let's say you have it's out of memory issues. Since I
Yeah.
assume you
So
were loading it in memory.
that's why I have this worker-based thing. So I have a limited number of workers and I have a limited queue size. So I'm doing everything in memory at the moment. But you know, the real way that you would want to did so the did you guys hear my part about Redis or not? Okay, so I said basically this in memory at the moment. It's not likely that it would actually, you know, overrun my available memory because I have a fixed number of workers and they can only feed so much work into the work queue before they basically have to wait to add more work. But if that was a real concern, you could use something like Redis, write it to an intermediate queue, like an in-memory queue, and then Redis would basically, you know, be your mitigating factor. Alternatively, you could write all these things to disk or something like that. You know, the real way that a super large scraper would work is that, you know, you would break up the crawler into, you know, maybe 3 or 4 different services. One would be just parsing the URL data, storing that on a separate, like, retrieval queue. Then there would be another worker that, you know, works off of that retrieval queue, and everything would have kind of persistent state and go back to a database somewhere. So you'd only ever be limited by your disk space, not by your memory. Yeah.
Any other questions? No more?